Welcome back to the deep dive. Today we're going deep on, well, deep learning. Specifically, a new development that has some folks saying, hey, is this the next evolution in AI?
Oh,
Lay it on me. Well, it seems like we might have a challenger to the reigning champ, the
yeah.
transformer model.
Yes.
It's
Transforms.
flexible, scalable, used in everything from like chatbots to image recognition. They're everywhere these days.
Right. Incredibly powerful tools, but
Right.
not without their limitations.
And the biggest one, scalability.
Uh-huh.
I mean, to make these models even more powerful, to scale them up, often means going back to square one, retraining the entire model.
Time-consuming and incredibly expensive.
Exactly. It's like every time you want to add a chapter to a textbook, you have to rewrite the whole thing.
That's a good analogy.
So that's where our subject for today comes in. Tokenformer,
Tokenformer.
presented in, get this, a research paper titled Tokenformer, Rethinking Transformer Scaling with Tokenized Model Parameters.
Rethinking transformer scaling. Bold statement.
So what's the secret sauce? How does Tokenformer do it? How does it handle this scaling problem?
Well, the key, like with so much in AI these days, lies in how it uses attention mechanisms. Now, transformers typically use attention to understand relationships between different parts of the input.
Right, like words in a sentence, pixels in an image. It's like the model is highlighting the important connections between these different elements.
Exactly. But Tokenformer takes this a step further.
Okay.
It applies attention, not just to the input, but also to the model's own parameters.
Wait, the parameter, those internal settings.
Precisely. Tokenformer treats those parameters, usually fixed, as learnable tokens.
So they can change and adapt.
Exactly. It creates what they call a token parameter attention layer, or patention for short.
Attention, got it.
This patention layer allows the input to interact with these parameter tokens.
Okay, I'm trying to wrap my head around this. So instead of just analyzing the input, the model is now analyzing itself.
In a way, yes.
It's like the input is the input is interviewing the parameters to see which ones are the most relevant experts for the task at hand.
That's a great way to put it.
And this design, this self-analysis, this has got to be what gives it that scalability advantage.
Yeah. You got it. You can grow the model by simply adding new parameter tokens. No need to retrain the entire thing.
So instead of rewriting the whole textbook, you're just adding new pages.
Precisely.
That's got to save a ton of time and resources.
Absolutely. The research paper shows that Tokenformer can scale from 124 million to 1.4 billion parameters.
Okay.
And in doing so, it cuts the training cost by more than half compared to traditional transformers.
Wow, that's massive. But how does it integrate these new parameters without, messing everything up? There's got to be a trick to it.
There is. The new parameters are initialized as 0.
0.
Might seem counterintuitive, but this helps preserve the knowledge the model has already learned.
Kind of like the LORAD technique we've talked about before.
Exactly. These 0 initialized parameters, they don't disrupt the existing knowledge. They learn and adapt gradually, and this helps the model converge faster.
So they're like apprentices observing the masters before they start contributing themselves.
I like that.
Very clever. And the scalability, it's not just theoretical, right? They actually tested Tokenformer on real tasks.
Oh yeah, and the results are promising. They applied it to both language modeling, tested it on a data set called Pile, and visual modeling, they tested it on ImageNet.
Okay, so it can handle both words and images.
Quite versatile.
Impressive. But one thing we know about large AI models is they often struggle with long sequences of information.
Right, like a really long research paper.
Exactly. So does Tokenformer face the same issue?
Well, this is where Tokenformer's design really shines. Remember how we talked about scaling up parameters without changing the token channel dimension? Well, this keeps the cost of those token-to-token interactions constant, even as the model grows.
So it's like adding more processing power without making the task more complex.
Precisely. It can handle those long sequences without getting bogged down computationally. A significant advantage for, well, any task that involves a lot of data.
Okay, this is all incredibly fascinating, but is there anything else about Tokenformer's design that surprised you?
Well, one more thing that I found interesting. Unlike other methods for scaling models like net-to-net, Tokenformer maintains its output distribution during scaling.
Output distribution. Sorry, can you break that down for me?
Sure. It basically means that even as the model grows, it represents and outputs information in the same way.
Okay, so it retains a consistent accent, so to speak.
Exactly. And this is really useful for continuous scaling, like when you want to handle new information from different sources.
So it can absorb new knowledge without needing a translator.
Precisely.
That's pretty neat. And they actually demonstrated this with the NWIC 8 dataset.
They did. So it's not just theoretical, it actually works.
Okay, so far, Tokenformer sounds pretty impressive. Scalable, efficient, can handle long sequences, integrates new information seamlessly.
The initial results are promising indeed.
It almost sounds too good to be true. But we've covered a lot of ground already, and we've only just scratched the surface.
We have.
So let's delve into the potential implications of Tokenformer in part 2. Stay tuned.
I'll be here.
Yeah.
Welcome back. We've explored the inner workings of Tokenformer, how its approach to attention and parameters really sets it apart.
Yeah, it's really quite clever. I'm starting to get why people are so excited about it. I mean, beyond the technical stuff, what could this mean for the future of AI? What are the possibilities?
Well, that's what fascinates me. I mean, Tokenformer isn't just some minor tweak, right?
Yeah.
It could fundamentally change how we build and scale these AI models.
Okay, I'm all ears. What areas specifically could it make a real difference in?
One that immediately comes to mind is mixture of experts frameworks, MOE.
MOE.
These are systems that they combine multiple specialized AI models, to tackle complex problems.
Okay, so instead of one giant model, you've got like a team of specialists, each one focusing on a different part of the problem.
Precisely. Think about, let's say, a medical diagnosis system. One AI expert analyzes the medical images, another one the patient history, and the third one focuses on the lab results.
Right. And Tokenformer, with its ability to manage like a massive number of parameters, this could be huge for those systems, for building and scaling them.
Absolutely.
Yeah.
It's like, well, Tokenformer is the conductor of the orchestra,
Okay.
bringing all these different AI musicians together to create a richer, more complex symphony.
I love that. Each expert playing its part and Tokenformer orchestrating it all. Amazing. What else? What other areas?
Another interesting avenue is parameter-efficient tuning.
Parameter-efficient tuning.
The idea here is, instead of retraining the whole model for a new task, which, as we've said, can be a real pain, we can just fine-tune specific parts of the model. In Tokenformer, because of the way it works, adding those new parameter tokens without disrupting the existing knowledge is perfect for this.
It's like giving an experienced chef a few new specialized tools instead of like making them relearn cooking from scratch.
Precisely. This could drastically reduce the time and resources needed to adapt AI models. Imagine being able to customize a language model for medical jargon, for instance, without that massive retraining.
The possibilities are pretty mind-boggling. Okay, I have to ask, what about the holy grail of AI? Integrating vision and language.
Ah, yes. The dream of a model that can truly see and understand the world the way we do.
Exactly. Could Tokenformer help us get there?
It absolutely could. Imagine a Tokenformer model that processes both visual and textual information seamlessly.
Okay, so like a model that could understand what's happening in an image and then write a description of it.
Right, or answer questions about a video by analyzing both the visuals and the audio.
That's like something out of science fiction.
It is the ultimate goal, and Tokenformer, with its flexible and scalable architecture, it could be a key stepping stone.
Okay. I'm getting chills just thinking about it. But let's step back to Earth for a second here. All this talk about powerful AI models, it raises questions about like the resources you need to run them.
Sure.
Isn't this technology going to be limited to like huge corporations with massive computing power?
That's a crucial point. As AI models become more complex, there is that concern that they'll only be accessible to a select few.
Right.
But Tokenformer, because it's so efficient, it could actually help democratize access to powerful AI
Really? How so?
by reducing the training costs and the computational requirements, right? Tokenformer could empower smaller organizations, startups, even individual researchers to actually develop sophisticated AI models.
So Tokenformer isn't just about making AI more powerful, it's about making it more inclusive.
Precisely.
That's fantastic. One last thing. You mentioned earlier that Tokenformer relies heavily on attention mechanisms.
Yeah.
What does that mean for understanding how these models work? Because right now, a lot of AI feels like a black box.
Right. We know it works, but we don't know why.
Exactly.
Well, attention mechanisms, they offer a glimpse into the model's reasoning process. They highlight which parts of the input the model is focusing on and how it weighs different pieces of information.
So it's like we can see the chef's thought process as they select ingredients and combine them.
Precisely. And Tokenformer, by extending attention to the model's parameters, could provide even deeper insights. you know?
So we might actually be able to understand how AI models learn and make decisions.
That's the idea.
That would be huge for building trust, especially in like healthcare or finance. Imagine understanding how an AI made a medical diagnosis or how a self-driving car reacted in a, complex situation.
Exactly. And that's why I believe Tokenformer has the potential to be much more than just, a technical advancement. It could be a catalyst for a more open, transparent, and collaborative relationship between humans and AI.
You've painted quite a compelling picture. Tokenformer sounds like a potential paradigm shift. But before we get too carried away, we should acknowledge it's not a magical solution.
Right. Of course not.
So in the final part of our deep dive, let's explore some of the potential challenges, the limitations of Tokenformer.
Sounds good.
And we'll discuss what it would take for it to really live up to its promise.
Welcome back for the final part of our Tokenformer deep dive. We've explored the possibilities, but now it's time to get real. Right. Time to see if Tokenformer can walk the walk.
Exactly. It's past the initial tests, looking good, but now it needs to prove itself in the real world. What are some of the challenges it might face?
Well, for one, it's so new. I mean, we need more research, more testing,
Uh,
to really get a handle on its strengths and weaknesses.
so it's like that athlete, just find it shows promise, but got to see how they perform in the big leagues. What kind of tests would you like to see?
Well, I'd be interested to see how Tokenformer does on tasks that require, real reasoning, common sense. We see AI models that can mimic human language, right?
Yeah.
But they often struggle with understanding context, intent, the complexities of, messy real-world situations.
It's like it's the difference between reciting facts from a textbook and actually understanding what they mean.
Exactly. So can Tokenformer really grasp those subtle nuances? Those things that, that we as humans just do naturally.
That's the big question.
It is. Testing it on those kinds of tasks, that's going to be crucial.
Okay, so real world testing, that's challenge number one. Any other potential limitations?
Another challenge is really understanding how those tokenized parameters actually work.
Mm.
I mean, attention mechanisms give us some insight, but we still don't fully grasp how those parameter tokens, especially when they're interacting with each other, how they contribute to the model's decisions.
So it's like we can kind of see into the kitchen, but we can't quite make out the chef's secret recipe. We know the ingredients, but not the exact proportions or the order they're combined in.
Yeah, a perfect analogy. Developing ways to really understand and interpret those parameter interactions, that's going to be crucial.
Especially, like you said before, if we're going to use Tokenformer in sensitive areas, healthcare, finance, all that.
Exactly. We need to know not just what the AI is doing, but why.
Right. Okay, any other potential pitfalls?
Well, even with Tokenformers, impressive efficiency gains, scaling up to the really massive models, those with trillions of parameters, that's still going to require a ton of computing power.
So even with a more efficient engine, you still need a pretty powerful rocket to reach those far-off destinations.
Exactly.
Sounds like there's a lot of exciting work ahead. But on that note, let's start to wrap things up here. Any final thoughts on Tokenformer and its potential impact?
Well, I think it's safe to say Tokenformer is it's a bold step forward. It has the potential to change, well, really change how we approach AI, how we build it, scale it, understand it. And I, for one, am really excited to see where it goes from here.
Me too. This is what makes exploring AI so fascinating. For our listeners, if you want to delve deeper, we've linked the research paper in our show notes.
Definitely worth a read. It's a testament to, to just how much incredible innovation is happening right now in AI.
And as always, keep those minds engaged, keep those questions coming. Until next time, happy exploring.